Hello engineers, innovators and problem solvers. Welcome back to Enginorium, engineering knowledge without limit. In today's lesson, we are going to learn how to draw the isometric view of the frustum of a regular hexagonal pyramid of base side 30 millimeters, top side 15 millimeters, and axis, which is also known as the length, 50 millimeters. Okay, so now what we need to keep in mind is that we are drawing an isometric view, but in order to draw the isometric view of this frustum, we need to get the orthographic projection. Now an orthographic projection is just like the top view, the front view, and the side view of the object you are drawing. So now let's draw our top view of this frustum. And so they say that the base side is 30 millimeters. So if the base side is 30 millimeters, that tells us that our radius would be 30 millimeters. So we extend it up to 30 millimeters to be able to construct our hexagon. So just draw a circle like this. So at that point we have our center. We'll divide the circle into two equal parts. Something like this. Okay. Now that we have this, with the same radius that we used to draw the circle, we can put at this point, cut here. You understand? We put at this point, we cut here. We put at this point to cut here. Now we have our hexagon by joining all sides. So from this point we have our hexagon here. We have the hexagon here. Yeah. Okay. So now that we have our hexagon, now the top hexagon, that is the top side, is 15 millimeters. That tells us that our radius will be 15 millimeters. 15 millimeters, radius 15 millimeters. So with the same center, we'll draw this circle again and produce another hexagon. So the same method we did here, we cut here, we take it to the other side, we cut here, and then cut here. So let's join them again. So joining here, join here, on these parts also. So this is our top view. When we view the frustum from the top, this is how it will appear. We also need to join the edges. Okay, so we join this place to this place. Okay, this point to this point. So in order to obtain clarity, we can just label each point, the inner hexagon, with numbers. We say 1, 2, 3, 4, 5, and 6. And the outer side with alphabet, this will be A, B, C, D, E, and F. So in order to get our front view, we need to project all this downwards. Project each point downward. This point also downward. Project this point. On this point also. Then let's give a little space, then draw a straight line. Okay, so now from this our front view, this is where we can see our axis, which is our height, which is 15 millimeters. So let's measure 15 millimeters. millimeters, then cross it over, cross. Okay, so from this point we are going to join this point to this point, dark, and this point to this point. Okay, so we join this point to this point, this point to this point, as you can see. Now we can now label, this is the top side and this is the base side. So we can say that this is 6, let's call this 6, and this is 1. You can say 1 prime, this is 2 prime, and this is 3 prime. And the base is this is F, this is C, this is A prime, this is B prime. So now that we have our top view and our side view, and we have our top view and our front view, we can now draw our isometric projection of the Frustum. We need to darken this point. So moving on, let's draw our isometric projection. So creating a base here, you can pick a base and mark any point on it. Now let's use our protractor for this. Let's mark out 90 degrees. Let's mark out 30 degrees on both sides. Okay, so since we said that after marking our points, our degrees, since we said that our base side is what? Our base side is 30 millimeters, and from what we can see from our top view, we have the distance from here to here is 60, which means that we are going to draw a square of 60. So let's draw that 60 lights, because that is not our focus now. 60, and our height is what? 50 millimeters. So we have our height 50 millimeters. This side also will be 60. So let's first of all draw a square, a box before we start. So let's mark up 120 degrees. We want 120 degrees here. We draw 50. This is our height is what? 50. On this other side, 120 degrees also. We draw our height upwards. Now we can join this side to this side, this point to this point, and this to this. So let's complete this box. We said here is 60, so let's take our protractor on this point, mark 60 degrees, then draw our 60 millimeters. Now let's start drawing our hexagon in this square. Okay, so from what we can see here, let's put this in this. We have this point at the center, so let's mark the center of 60. Let's mark the center of 60 here. And from what we can see, we have 30 millimeters in this. So if we divide this point into 2 and take 15 millimeters from the center out here, mark this point 15 out and 50 in, making it 30 millimeters, which is the same as this. This is 30, this is 30. We do the same thing here. Mark out the center, then we take 15 millimeters in we'll take 15 millimeters out. And this point we mark the center. We mark the center. So now we have this. You can join this to this point, to this point, and this point to this point. Okay. So this part will be light details. Light details. Since they are not going to show from the view. Now for the top, we say that this is 15 millimeters, which means that the square that we are going to draw in order to be able to draw this will be what, 30 millimeters. And so we'll mark out the center. The center will be 30, and this is what, 30. 30. So now that we have the center, we need to mark out 15 in and 15 out. Okay, so we take 15 millimeters in and 15 millimeters out, making 30. We are trying to create a square of 30, so take 15 in and 15 out. So draw a very faint line from this point to this point, and from this point, the same thing we did here, we also do here. Okay, so we take out the center here with 2. We also mark out the center. So we take 15 millimeters in, okay, and we have 15 millimeters out. Also 15 millimeters in and 15 millimeters out. Now we have a square from this point to this point, and decide to join it. Okay, and a square from this point to this point. Okay. So let's mark off the center also. Okay, so now from this point, now we know that from our top view we can see that this part is what, 15 millimeters, and each side is 15 millimeters, which means we are going to take 7.5 in and 7.5 what, out. So let's look at it carefully. We have this 5, 6, 7.5. So we'll take what, 15 here, 15 here. You see, then this part is at the center, as you can see, so let's just join it to the center like this. So here also take 7.5 in, 7.5 out to make what, 15 millimeters side. Okay, and we can now join all these points to the center like this, like this. Okay, so now that we have something, we have this, we can now label it. Now we have this point to be what, 1. We have this point to be 2. We have this point to be 3, 4, 5, and 6. So we can now, and this point, the outer point here to be F, here to be A, B, C, and this is D, and this is E. So from what we can see from the top view, E is joined to 0.5. So let's join E to 5. To 5, that. And then F is joined to 0.6. So let's join that. And 1 is joined to point G. So let's join it. 2 to point B. Yes, 2 to point B. This is B. And 3 is joined to point C. So since this is not visible from the point you are looking at. This will have to be what? Dotted line, to show that it is what? Invisible from our point of what? Origin, from our point where we stand to look. And 4, we join the point D. So this is D, so we have to join it with also a dotted what? A dashed line. So we now have our what? Our frustum, our regular hexagonal frustum, drawn from the top view to attain what? Our isometric view. Thank you guys. I hope you understand this video.